invitation to talk today. Thank you all for choosing to be here instead of the Bitcoin, which is, the hottest thing. I'm going to try and talk about two things today. I'm going to try and talk about Quandl, where it came from, where we are now, and where we aspire to go. And I want to talk about Quandl in a Python context, and that is specifically how to get data into Quandl with little or no difficulty. I'll start by contextualizing about myself. I'm a computer engineer by training. I fell into a career on Wall Street where I spent 13 years before starting Quandl. In the last few years before the inception of Quandl, I was running my own sort of analytical consulting company without the luxury of the Bloomberg machine that I enjoyed for many years on the street, and I became acutely aware of how difficult it is to work with data when you don't have the luxury of that device beside you. Data in the wilderness is tedious and time-consuming and painful to work with. Sometime in 2010, I had a mild eureka moment. I was sitting there Googling for the price of oil or something like that, and it came to me, and I thought, why is it that there's one website on the internet that has sort of consolidated the sum total of all human qualitative knowledge onto one site? If you want to learn about a particular TV show or the history of Rome or Genghis Khan or molecular biology or how to split the atom, there's this one website you can go to and you can learn it. And that website is, and I thought to myself, that's brilliant. Why then is there no Wikipedia for quantitative information? Why is it that quantitative information has not been consolidated in such a beautiful way like qualitative information has been? And I sort of walked around scratching my head about that for a while, and then I decided, okay, I'm going to do it. I'm going to consolidate all numerical data on one website. Turns out it's an extremely difficult problem. My first thing I did was I dusted off my program skills from the 1990s, and I hacked up this crude little prototype of what I thought such a website should look like, and it was slow and buggy and had only a few thousand data sets. And amazingly, people started to use it anyway, and we had a few thousand users. And I thought this was a great affirmation of the fundamental value prop. Even if you build a cruddy little prototype that barely works, people are so desperate for organized findable data that they'll use it. So I took this story to a bunch of investors, angel investors, Toronto, and I said, I'm going to build the Wikipedia of numerical data. Fund me. And they said, Wikipedia for numerical data? Brilliant. Wikipedia doesn't make money, not going to fund you. I said, no, but this is going to be Wikipedia for data, and you and me, are going to own it, and we're going to make a lot of money. And I told them how we're going to do that, and I'll tell you in a moment how we're going to do that. And they took the bait, and they wrote a check, and we built the Quandl that is there now, www.quandl.com, which in its current state has about 8 million data sets. So then I took that version and I flew to the West Coast and went down to the Valley, and I told the story about Wikipedia for data, and I said, we need more money to get more data and continue on this mission to build this. But they need even more oomph down there. They need more audacity. So I said, look, what I'm going to do is I'm going to do to Bloomberg what Wikipedia did to Britannica. So that's nice and audacious, right? And that's what they like in Silicon Valley. They like big, audacious objectives. But the real reason Silicon Valley is interested in this is because of the macro theme that interests them right now, which is data. We're kind of in what you might call, I call it the Netflix moment for, I thought I brought water up here somewhere. Maybe here. I call it the Netflix moment for data. So Netflix was this company that was mailing out DVDs and competing poorly with Blockbuster. And then one day something systematic changed on the internet, and that was bandwidth. Bandwidth increased to the point that you could stream stream a video, a movie into the home, and all of a sudden Netflix conquered the world and Blockbuster is dead, right? So it's something fundamentally changed on the internet. And I believe, and my investors in Silicon Valley believe, that the same thing is happening right now with data. Data is, there's a transformation happening, where open data and big data are but components of a much larger phenomenon. And that phenomenon is that data is going from scarce to utterly ubiquitous. And that is a macro trend that is happening, and for a company that's in the right place for this seismic shift can potentially do very well. So Quandl right now has, so like I said, some 8 million data sets. We have, what's interesting about Quandl, okay, so there's 8 million data sets on Quandl, not a single one of them is unique. Every single data set on Quandl you can get elsewhere on the internet. Nevertheless, every day some 10,000 people come to the website and download data, and we serve up several million data sets per month. So to me, this is affirmation of the value prop, that the future, given the data is sort of transitioning from being scarce to ubiquitous, the value prop around data has to change too. You can no longer, historically, you take a company like Thomson Reuters, they built a massive business model around a commodity that was scarce, data, right? If you have a commodity that is scarce, you can put a high price on it and you can sell it. But when that commodity that was once scarce suddenly becomes far less scarce, the old value prop doesn't work. And so our bet is that the new value prop is not about the data itself, it's about organization and curation and availability and flexibility and usability. And so the fact that we can put 8 million data sets on our website that are totally not unique and still garner, a lot of heavy usage, sort of is affirmation of that. The price point of $0 also helps.
Is your data copies of the other data, or is it just linking to the other data?
So it is conceptually linking, but it's actually cached. So what it does is, the fundamental value prop of Quandl, which actually I will demonstrate right now, is this. You go to Quandl and you say you want data on Bitcoin. I'm sure they're using it next door right now. You go to Quandl, you get sort of kind of a search experience, and Quandl shows you all this data that it has on this subject of Bitcoin. And you click on the data set of choice, and then you get the data. Now, Quandl has sourced this data from elsewhere, but is presenting it to you in one standard, immediately usable format. And here's the real value prop. You press this button here and go like this. And now you've gone from needing data on Bitcoin to having data in the format of your choice on your computer. This?
Yeah, download the data.
That much, zero. It costs $0.
And that applies to anything?
To all 8 million data sets. Costs $0, so it scales well.
Yeah, so how do you make money?
I'm going to come to that. But so when I make, this is my standard VC demo. I type something, search and download. If I'm pitching to someone who's never worked with data, they go, big deal. You just download a data set from the internet. I can do that, right? But you pitch this to someone who's worked with data, right? And they see the value prop here right away. They know that they spent half their bloody lives trying to find, clean, format, and validate data. It is a vicious time vampire, and that's not where you want to spend your time, right? So this is the value prop. This is it. You go from needing data to having data in seconds, right? That is the value prop. Now, yeah, please. So I don't. What I do is I'm very transparent about where the data comes from, and you make your own quality decision on that source. So for example, here, this data is sourced from a website called Bitcoin Charts, and you can actually click right back to the original source of the data, and then you make your own assessment of the reliability of that source. So transparency is my panacea for reliability. I defer. So just so I can transition into, please.
So do you show every source for that data, because that could have come from 10 different sources?
Yeah. So the idea is if you go,
and then you leave it up to the user to figure out which is the most reliable.
Right. So Quandl users get a sense in time of we have about 500 different sources. And depending on your domain, you spend a bit of time on Quandl, you get to understand what sources serve your needs. And you tend to then start doing this kind of thing where you say, well, I only want to see data from Bitcoin charts, for example. And you do some filtering. Maybe you only like those two sources. So that's the idea.
And what about frequency data, like intraday?
So right now the highest frequency data on Quandl is daily. Intraday data is sort of the next step for us.
Isn't that like harder to get?
Yeah, I'm going to tell you how I'm going to solve that too in due course. There's so much to look forward to. I want to sort of gradually transition here into the technical usage with Python, with a few digressions along the way. But the first thing to do that, what you sort of need to know here is that pick this data set again. So every data set on Quandl has a unique identifier. It's like a ticker code. This guy's ticker code is Bitcoin / whatever. But so if, for example, if you wanted to know the unemployment rate in the United States, you would go Fred/unrate. And the idea of the nomenclature here is that the first half of the ticker is the source, and the second half is the unique identifier within that source. We try not to invent tickers. We try and reuse the tickers or the unique IDs that various sources have created. So if you wanted unemployment data, you'd need to know that this is the ticker. How would you find out that in the first place? Well, you would do a search for civilian unemployment. Oh, sorry, the ticker, by the way, is down here. This is where you get it from, which will prove important when you want to pull it into Python in a moment. You can search for it and find it that way too. And for quick and easy, it's right there. So these are the unique identifiers that you'll use to pull the data into Quandl. Quandl search is quite rudimentary. One of the challenges I have is that Google sets a very, very high standard for the quality of search. You can type into Google kind of roughly sort of what you're looking for with 8 spelling errors, and sure enough, there it is. Google put it at number 1, right? I can't do that so well. You put one little spelling error in here and you get nothing. We're working on that. Google's had 15 years and spent about $100 billion on the problem.
Because money is not an issue for you.
And given our revenue level, improving search on Quandl is important. It's actually my second most important problem. It's more of a cost than a problem, because search is a solved problem and we can do sort of better on that. But there's one unsolved problem that we have to work on, and it's my number one priority, and it's called I call it curation at scale. So Quandl has 8 million data sets, and those 8 million data sets are curated by 3 individuals. That's a pretty good ratio. It's a testament to the intelligent technology that's behind Quandl. But the important thing to notice is that there's still humans behind this. Why is that important? Well, it's important because it means I can't scale technologically. I cannot build some magical robot that will crawl all over the internet and pull in all the numerical data on the internet and parse it and format it and understand it and label it and organize it. You cannot do that by computer science. It is beyond the realm of the possible. There's a reason that Google didn't do Quandl themselves 10 years ago. And the reason is it can't be done by machine. You must have humans to curate. And in this audience, the nuances of working with data, I don't need to explain that to you. So this creates a scaling problem for me, right? If I can do 8 million data sets with 3 people, great, but how do I get to 80 million data sets? Well, I could hire 27 more people, but again, given the revenue level, that gets tricky, right? So, and I want to go bigger than that too. And the other problem, of course, is that if I'm really on a mission to disrupt the incumbent data delivery mechanisms, I can't go about doing that by doing exactly what they do, right? This is what the Bloombergs and the Thomson Reuters of the world do. They have armies of people typing in numbers, fixing numbers, cleaning numbers, and that's why the price point is what it is. So I can't solve technologically, and I can't just hire endless people to solve my scaling problem, so what am I going to do? Well, this is the billion-dollar question for us here at Quandl, and the billion-dollar bet we're taking is crowdsourcing. We think we can solve this problem by crowdsourcing. Now, how am I going to do that? Yeah. So the idea there's two tricks to this. You have to empower anyone on this planet to add 1 or 10 or 100 or 1,000 data sets on Quandl, and you have to make it easy to do. You have to create frictionless mechanisms to do that. That is necessary but not sufficient. The second problem is motivation. You have to want to do this. There has to be something in it for you. For motivation, my plan is to reach to something that has a long history of motivating, and that is money. As one of my partners says, we are all coin operated. So my plan is to morph Quandl into a platform or almost a marketplace. I want to create a situation where someone who is capable, highly capable, of curating, organizing, or maintaining a data set in any particular niche. It could be one single time series. It could be a data set of 20 time series or 10,000 time series. I'm going to give them the tools to do that and a mechanism to monetize on Quandl. What is that mechanism? Put the data on Quandl and put your price tag on it. Every day, some 10,000 people will come to this website, and hopefully that'll grow, and they'll find your data set. And for those people who need that data, need professional grade data, they know what it costs to buy it. And if there's a price point on Quandl that is substantially lower than that for the same caliber of data, then you have two happy parties. You have a curator who's motivated because he or she is getting paid, and you have a data user who's just found a quality data set at a price point that's affordable. So that, in a nutshell, is how we hope and pray that we're going to go from zero revenue to substantial revenue, and thus grow the thing into the true Wikipedia for data. So that if I were to put a little crystal ball and look a few years into the future, if everything goes delightful, what we'll have is a situation where there's still tens of millions of data sets on Quandl that are free. Perhaps many of those are curated by third parties for other reasons other than financial motivation, whether it's altruistic or self-interest. But then there'll be a premium layer on top. So if you need intraday data, high frequency, something, it's there, it's available, and it costs this much. But that hopefully will be the lowest price available, because now you're only paying for the curation. You're not paying for somebody's fat margins who has to maintain an army of 350 data curators. You're paying the actual true cost of curating that data set. And with that, let me do the technical demonstration of how to use Quandl in Python. So here we go. So I'm going to just grab these three. So I'm going to import Quandl, which is the Quandl package. And here is the fundamental value prop. I'm going to get the entire history of Apple stock price into a data frame in one call. So with this call right here, I've asked Quandl to go to source wiki and grab ticker AAPL. And what I've got now is the entire price history of Apple stock, open, low, highs, low, volume, dividends, splits, and all adjustments. The data set on Quandl, because it's easier to look at here. www.quandl.com wiki/AAPL. So this is the data set that I just pulled into Python. It's actually the best source of end-of-day stock price data on the internet, for the simple reason that it's the only source you'll find that actually has the dividends and the splits and the nominal prices and the adjustment prices in one nice, easy data set. And it's unencumbered. It's wiki, it's open data. You won't find any other site on the source is called wiki. You won't find any other end-of-day stock data on the internet that's not encumbered by some limitation on what you can do with it. That's a digression. So here it is in Python then, same data. That's the latest observation there. We try to not do any analysis. We want to be a pure data feed, but we do provide a few basic slice and dice and transformation tools because they're so fundamental. So for example, if you wanted to say just column 11 of that data set, which is the adjusted close, you could do this command here. And this is just telling Quandl, hey, give me only column 11, which has now happened. And then just to show you what that might look like, I can then say, okay, let me plot that. And there's the complete history of Apple stock price since its IPO. Now, a couple other things that are handy. 5 minutes, my God, I've got 15 minutes to cover. Okay. I'll show you the merging. Here I'm going to grab two stock prices at the same time. I'm going to say, Quandl, get me Apple and get me Microsoft and merge them. And if you ever merge time series data, you know the pain of that. If there's a missing data point or different time frequencies, it's not pleasant. Quandl will do that for you, automatically clean it all up. I've also said, hey, Quandl, start at beginning of 2013. Don't give me anything before that. And pre-transform it with an RDiff. That's the percentage difference between successive data points. And I did all that so that once it's in Python, I can just do a quick little df core here. And anyone care to guess the correlation between these two stocks, daily data? Nada. And that's because the companies really don't do anything the same. I wonder, actually, there might be a time lag. If you did Apple with a 1-year time lag to Microsoft, maybe since.
Today, they are about to catch up.
Okay, well,
The same.
okay, well, that's something. We'll see that in the data, no doubt. Okay, because I've got probably only 4 minutes and 50 seconds left. I want to show one more thing. I want to just give a little sneak preview of the curation mechanisms that we're building. Let's say you have so these are the tools that will empower data curators to put data on Quandl. So you might have, say, a file data.csv. It looks like that. You can just put it up on Quandl by doing this, Quandl upload data.csv. And what happens here is that Quandl sees this, parses it, and puts it up on the web. And now this is the 8 millionth and 1th data set on Quandl. And it's right here. So this just went from my local computer onto Quandl. Now this is kind of useful because now this data set is imbued with all the attributes that Quandl gives to data. So it's in the cloud, it's persistent, it's shareable, it has an API, it's mergeable with all 8 million other data sets, which is convenient. The real power, though, is in something like this. I might have written a scraper, Python scraper. So this is a scraper that scrapes, in this case, stock prices from somewhere and spits them out as the CSV. So I can also do this. I can also do Quandl upload. I can do this. Run my script, Python scraper, and pipe that on in. That's a fundamental, that pipe operator. We learned about that earlier. And I can pipe that into Quandl upload, Quandl upload, and Quandl upload. And what's going to happen here is now this data set, so I just run this scraper, it does its scraping, and it sends it up to Quandl. And now it's actually scraping Facebook prices from somewhere. And voila, I've just built this data set on Quandl that's just like any other data set on Quandl. But here's the really cool part. Drum roll, please. Quandl schedule. I run Quandl schedule, and I give it scraper.py. The scraper gets sent up to Quandl server. It lives on Quandl server. Quandl just keeps running it and keeps the data set up to date for you. So if you're in the business of scraping data, this is a great solution because you write your scraper once, give it to Quandl. Quandl just keeps running it, keeps your data set perpetually up to date. Your data set now has an API. It's shareable within your organization or with the world or with just privately for yourself or whatever you want to do there. You can do this with 1, 10, or 1,000 or 10,000 data sets. This is an example of the fundamental tools that we're going to hand to curators so that they can build a data set on Quandl and either do that for their own use, for self-interest or for their organization, or indeed put a price tag on it and monetize it. And that is the 27-minute Quandl overview. I thank you so much for your attention.
Who essentially validates the data? Like, is there, you can have people curate it, but at the end of the day, if an enterprise system at, say, a bank wants to use this data, who's going to say it's 100% correct? Because the bank can't afford for even one data point to be wrong.
Correct, but there is no universal validator right now. Right now, you just have trusted brands, right? So a bank will trust Reuters or Bloomberg because of that name. It's a reputation they built up over decades, right? So what we're going to do is empower somebody to build up a brand reputation from the bottom up, right? There's no other solution to that. It's a sort of, you climb the value ladder.
So, there's monetary penalties for lawyers. They screw up too. So if we use their data and they get it wrong, they have to pay us some fee for the mistake. So that was one thing. But my second question was, where's the data to be stored? Because there's going to be, if this goes out, you have a huge amount of data. So who pays for that piece of it, and where does it go?
Well, so right now it's stored on our databases in a cloud server. You got to remember, the type of data we're storing, it's not like it's video or something like that. It doesn't actually take up that much space. I mean, our 8 million data sets is stored in a database that is a few gigabytes in size. It's nothing. Numerical data is not that space consuming.
Just on that to clarify, so therefore your whole target data sets are going to be daily at most time series, right? You're doing time data and you're not doing tick data, and that sort of gives the scope.
No. I aspire to everything, but I have to start somewhere, right? So eventually we'll increase the frequency and we'll move out of the time series domain. Moving out of time series is actually, in some ways, easier because it just then becomes simple tabular data.
Let's say I have a data set up there and I charge you $100 for it. What's to stop somebody from downloading my data set, copying it, pasting it back up there for $99?
Yeah, so that's my job to protect you from that. There's a nice natural protection with data is that it stales the next day or the next week. If you're updating a data set regularly, then as soon as some delete explicative starts doing that to you, we chop them off, and yeah, maybe you got away with it once or twice, but that's a drop in the bucket compared to the.
What's your cut?
I've been forbidden to answer any more questions. No, seriously, I seriously look.
It has to be depending on things.
Yeah, I don't know, maybe 30%. We're going to figure that out. James, thank you for indulging me.